What's a tangent? Describing what a tangent is. If I drew a circle up here and I said, come on up here and draw a tangent line, describe to me the line you're going to make. 20?
A line that is on the outside of the circle, that has one point that touches the outside of the circle.
There touches the circle in one spot. Now I want to introduce to you a line that intersects the circle in two spots. Anybody want to try and pronounce it? Secant. This is a secant. All right? A line that intersects the circle in exactly two spots. A secant. Secant. Go through me right now. What are the three types of angles you find inside a circle? Three types of angles we could find inside a circle. 11? Inscribed. 21? Central. Last one? 3? Floater. Today, how do you find an angle that's on the outside? Okay, how do you find the angle on the outside? And good news, as long as it's on the outside, it's the same rule. It doesn't matter how it's formed. What I want to do first is, in this diagram right here, tell me how angle B is formed. This is a what and a what that's forming angle B. I just want to make sure we're good with our vocab. Let's go. 23. What are these two here? Not here. Thank you very much. I had a feeling. 5. 2 tangents. So these are 2 tangents. All right. How's angle A formed in the second diagram? How is angle A formed? A what and a what here? 6. Good. 1 tangent, 1 secant. And then finally, diagram 3. How's angle A on the outside formed? 13? 2 secants. I don't care how it's formed. If your angle is on the outside, we find it one way and one way only. And here it is. Angle on the outside. You're going to do 1/2 of 2 arcs again. With the floater angle, you did what to the 2 arcs inside the parenthesis? You added them. If the angle's on the outside now, you subtract 2 arcs. All right? And I can't really, all I'm going to put is it's half the difference of the 2 arcs. And I'll show you what I mean by the 2 arcs here now. So subtracting 2 arcs and taking a half at the end. I'm going to go backwards. Look at this one right here. Angle A. If I ask you to find angle A, and I'm going to ask this question today, inside or outside? Outside. Discussion's over. It's going to be 1/2, 2 arcs being subtracted. Now let's talk which 2 arcs. You always do the arcs inside the angle. The 2 arcs inside your angle, not on the outside. The 2 arcs inside the angle. Bigger one minus smaller one. So what's the bigger of the 2 inside on this diagram? CE minus the other one, BD. That is how I would find that angle. Okay? Bigger one minus, and yes, you can always assume that the further one is the bigger one. How would you find angle A on the second diagram? Half of, name the 2 arcs in between you want me to subtract. Name the 2 arcs in between you want me to subtract. 24. Good work. Minus. Good work. BC. And then finally, let's finish it off with this first diagram here. How do I find angle B then? Still going to subtract, but tell me which 2 arcs I should be subtracting here. 16, which 2 arcs should I subtract here? Good, thank you for using 3 letters. Great job there. Minus AC. Are we all good now? If it's on the outside, I don't need to say another word. We know how to find it, no matter how it's formed. Questions? All right. Last thing, there's a couple angles that don't follow any of our rules. They're not inside and they're not outside. So what the heck do I do to them? Take a look at this angle here. Angle CAB. Everyone see what happened? What?
Can you go back to the last one?
What did I?
For the last one where it's ADC minus AC.
Yep.
What if there was no D? Would you
Oh, there better be. But you always do the major one minus the minor one.
But like, if there wasn't, would you have to say AC major minus AC minor?
You could, but we're going to plug in numbers for those. So I would never need to see what the actual arcs are.
Okay.
But there should be a point on there so you can name it correctly, other than AC. Okay, good?
Yeah, thank you.
Yep. Okay, CAB. Is it inside? Is CAB inside the circle? Is it outside? It's not really anything we've talked about, right? Why isn't it inscribed, first of all? Some people may say it's inscribed because they see point A on the circle. Why isn't this inscribed, Paul?
It's not formed by two chords.
Yeah, there's one chord, but the other one's a tangent. So does everybody see this follows no type of angle we've talked about, inside, outside, central, inscribed, floater, nothing. I actually refer to these as tweeners. A lot of people don't like that word, but why do I call them tweeners? It's like a half and half, isn't it? Part of it's inside, part of it's outside. It's a tweener. If it's formed by a chord and a tangent, you take half its arc measure. Okay, half its arc measure. Some of you, I'm sure, could have used that last night. All right, a couple of those angles I asked for would have been a tangent and a chord. You could have taken half its arc. So CAB is going to be found by taking half of arc CB. All right, that's the rule. I take half of arc CB. It's a tweener. Not inside, not outside. Half and half. Oh, yes, Paul, go ahead.
Arc AB or CB?
CB.
Oh,
Why? You take half its
I don't-
arc.
I don't know where this point C is.
C is just this point. It's a point on the line here. So CAB, that angle right there. And you see how it's drawn to arc 140?
Yeah, no, I get that. But
Yep.
Like the arc wise, this is not arc AB because it doesn't look like. Is C?
Okay, all right. I see what you're saying there. So yeah, I should be putting AB. I got you. Thank you. I got you. Thanks, Paul. One more type that we've never talked about, a secant and a chord. A secant and a chord. I'm talking about angle BCD. Why am I not talking about BCA? How do you know I'm not talking about BCA? We got a name for that. What's that called? BCA is what type of angle? That's inscribed. So I'm talking about the other one, BCD. And you're not going to like this. Sorry. You want to know the rule for a secant and a chord? I don't got one for you. I don't have one. But I am still going to ask it, though. So even though there's no rule, how can you still get to that angle measure? Avery, go.
You could find the angle measure of angle BCA and the linear pair. So subtract it from 180.
Find the inscribed, and it's linear pair. Done. So you can still find it. You don't need a rule, though. All right? It's not half the arc. So all good? So now we should have something for every type of angle I throw at it. And if not, figure out a way. All right? Start finding angles around it. All right, let's start getting to work here. Calculators out if they're not out already. Let's get to work. We got 20 minutes here, so making every use of every second. I know I just had this up, so we already automatically know the rule, but is this angle inside, outside? Neither, right? It's a tweener. But how's it formed? How's it formed? How is this angle formed? By a what and a what? Because that's going to tell me what my rule is, if there is a rule. One, Meg, how's this angle formed? CAB, by a what and a what? Tangent chord. It's formed by a tangent chord. I have a rule for that, and it is 1/2 its arc measure, 140. So CAB, 70 degrees. I have a rule for a tangent and a chord. I don't for a secant and a chord. Remember that. All right, let's keep moving. How about 2? Find the measure of minor arc AB. Minor arc. Remember minor arc? One that's less than 180. And I gave you 160 as B, A, and I don't have another letter there. Minor arc AB. Any help here getting to it, Paul? Because there's 2 ways to do this. Go ahead. Your way, Paul?
I was going to do 160 times 2 to get.
So you're finding the major arc first.
Major arc,
Yep.
and then-
When that'll be 320.
Yeah, and then 360 minus 320 to find minor.
Yep. Did anybody do the linear pair to 160 and then multiply that by 2? There's the other way. Perfect. Yep. Either way, minor arc will be 40. All right, minor arc will be 40. All right, 3. Where's the angle I'm asking for? Inside or outside? Okay, our discussion is done. Once you tell me it's outside, there's nothing else I got to ask for you. One rule only. I take half the difference of the arcs in between. Done. There's no more. Is it this type, this type? You tell me it's on the outside. One rule only. So 90 minus 20. We're taking half of 70. 35 degrees. All right, now we're getting serious. This is honors level right now, number 4. Where's the 38? Where is it? Outside. Discussion's over, right? That 38 came from taking 1/2 of 2 arcs being subtracted. Agreed? What's the smaller arc? X. So I'm going to do something minus X. Agreed? Ooh. All right. Honors kids, let's talk. How do you find that arc? Because that's the one I got to plug into the formula. Well, I gave you the 140, right? So if you have to in your calculator right now, if you know that arc's 140, how many degrees do I have left over to play with? If that's 140, how many do I have left over to play with? 220, right? I got 220 to play with. That arc's already X. And I know these two have to add to 220. So if that one's X, how can you represent the one I'm looking for now if you know both of them have got to give you 220? 220 minus that X, right? Everyone sees that. There's 220 left over. I know that one's X, so this one's got to be 220 minus X. So it's going to be 220 minus X minus X. Everyone all right where 220 minus X came from for that arc? That's honors level right there. I'll clean up the inside here. 220 minus 2X. And we talked about this yesterday, right? If you want to distribute, distribute. If you want to multiply both sides by 2 to cancel out the 1/2, then you do that. All right, you do what you're comfortable with. I'm a multiplying by 2 guy, so. And then you guys are good from here, hopefully algebraically. And hopefully we all end up at 72 degrees. Anything here on the 4th one before we get to 5? All right. 60, where is it? Inside, outside, in between? All right, then make sure we set it equal to our outside formula. I need your help again because I only know it's going to be minus x, the smaller one. How about the bigger one again? What's the deal there? I'm going to throw a number on that one. Let's go to the numbers now. 13. How can I figure out that one?
360 minus that.
There we go. I had 360 total to work with. That's x, so subtract that. Okay, do we have anything before we go to the next one? Because it's, I'm going to raise the level big time in here. If you thought it was raised already, it can go further up. Anything you want to ask? You ready for this next one? You know what's coming. Here they are, king size. Now anything's fair game. Inside, outside, whatever. Anything is fair game now. Let's do this. Read the directions. Yesterday, I put something got bisected in there. Today, I put AB congruent to AD in there for a reason. Don't just overlook it. Anybody, what is AB and AD? Name them in the circle. Those are, from day one, what are AB and AD? Chords. Didn't we have a fact? If the chords are congruent, so if AB and AD are equal, the chords are equal, so are their arcs. Name the arcs that are congruent then. If AD is congruent to AB, name the two arcs in this diagram that should also be congruent because of it. Come on now, let's go. 7. Arc AEB, great job. Congruent to arc AD. Everyone, well, look at me, plop a little theorem in there too. What am I thinking? Oh, and look at the next fact. Arc AB, 150. So guess what arc AEB is also? 150. Just by knowing that theorem. Yesterday, the key to success to these king-size circle problems is what? If you know all the arcs. If you know all the arcs, pretty good bet that you'll be able to get every part right. All right, let's go. Any other arcs you want to throw at me that you know? Tammy, go.
BD.
BD.
Yeah, it equals 60.
How'd you get 60? Go ahead.
So 150 plus 150 equals 300, and then 360 minus 300
It's one arc I'm missing from 360. Everyone agree? So that arc is going to be, yes, 60 degrees. I want every little arc too. We got the main ones down, but I want EA, I want EB, I want AD, which I already have 150, sorry. Any other arcs we know? Come on, dig deep here. Charlotte?
EA is 30.
Good. Yep, go ahead.
180 minus 150.
I told you yesterday, nobody ever sees these. It drives me nuts. We got a diameter. You got semicircles here, 180 degrees. 30. Let's see, I'm missing one more arc. How about EB there, kids? Arc EB? 120, because I had to add the 150 with the 30. All right, so I think I'm good, right? I got all my arcs. You guys ready to dig deep now? We should be able to do all this no problem if I have all the arcs. Oh, look at this. That was convenient. I already have part A done. Arc AD 150, and that'll happen. Maybe the first two are done for you. All right, here we go. BAD. Got to figure out where it is. Inside or outside? Inside. So therefore, it's a 1 of 3 type. Is it central? Inscribed. Yes, it is. So we better know the rule. Take 1/2 of. What arc you going to take 1/2 of? And what's the degree measure already there? 11. Take half of.
Arc B.
60. 30. Put it in your diagram. You might get stuck along the way and not know a rule, and that 30 may be pretty helpful to you. 30. Part C, measure of angle ACD. Inside or outside? We're done, aren't we? We're done talking. It's outside, so you better be subtracting 2 arcs then. ACD. Highlight it if you need to see what 2 arcs are in between it. ACD, what are the 2 arcs in between it? Woo! 18, what are the 2 arcs in between?
150 and 60.
Great job. 150 minus 60. Stop me if you don't see it. I'll highlight them for you too. 40, 45. What's up? Where'd I get the 150? All right, yep. Ready? We'll move angle ACD. See the 2 arcs in between? Yep. Hey, highlighting helps too. All right, so let me just put that in that was 45. May need it. D. Angle EFB. Inside or outside? Inside. Ready. Central.
No.
Inscribed.
No.
Therefore, it's got to be floater. So somebody should be giving me 2 arcs added up now. Its arc and its vertical angles arc. EFB. Just want to make sure I got the correct one there. 16. What's the arc measure that belongs to EFB? 120. What's the arc measure that belongs to its vertical angle? 13.
150.
150. Ooh, that's a large one, huh? 270. Half of that, 135. Haven't scared anybody away yet? EDA. All right, where is this sucker? EDA. Inside or outside?
Inside.
Central. Inscribed. Got an inscribed angle on our hands. Now, hey, here's another thing too. You freeze and you don't know that's inscribed. Could I still find it? Vertical, 180 degrees in a triangle. You still do it. Still can do it. 15 degrees. And then I got one more, EDC. Inside. Outside. Tweener. Everyone agrees? How is that angle formed, by the way? Let me highlight that sucker. EDA. EDC, sorry. How's that angle formed? What's this right here? CD. That's a tangent. What's ED? Diameter, which is also a chord, right? So one way you could do this is take half the arc, which is the rule I gave you today. What's its arc measure? So I could take half of 180, or does anybody see a theorem from a previous day here that I could also get 90 degrees from? If you didn't see it was a tweener and it was half the arc, you could also, Tammy?
A radius perpendicular to a tangent.
Radius drawn to a point of tangency is perpendicular. So that's the other way I could get the 90. Either way, you could still get it. All right, either way. Go ahead. What do you got for me, Avery?
Is it fine if I did it a different way?
Did you do like vertical angles, 180 degrees?
I did 180 degrees.
Fine. I'm never ever going to tell you to do it one way, ever. All right, whatever gets the job done in here and it's correct, fine. You guys got this one on your own in the last couple minutes. I got this off an old Regents. Now that we're taking it Regents officially, I want to start putting in some old Regents questions so you guys understand the level we're going at. So this came off of previous Regents exam. And also to show you that what the heck we're doing is going to be on there. Is angle P? It's obviously outside, so I know you're going to subtract 56 from the bigger one, but how'd you guys find the bigger one? What's this here? Diameter forms a semicircle, so this arc's going to be 180. What did that end up being? 124. And what was that? 68. You took half of 68. So 34 degrees. What's going through your mind? How many right now are going through your mind? Oh, this Regents is going to be easy if this was a Regents question. You're going to remember this, though, 2.5 months from now? Right? It's easy because we did it today, but 2.5 months from now. Woo. All right, all good? Monday we're going to review. We'll review again for the quiz. All right? All right, I'm good. There's only 2 minutes left, so. Also, I will not be here after school on Monday, so whatever questions you have, bring them Monday to class. All right, I can't stay after on Monday, so whatever you have, ask. Bring all your questions Monday. Days 9, 10, and